Hello everyone, welcome back to VSAN channel. In this video, we are going to discuss the differences between virtualization and containerization. And as you know, virtualization and containerization has been successful. So virtualization has been very popular in the market for the last 2 decades, like 20 years, and containers are very successful for the last close to 10 years, but not exactly 10 years. So since Docker got into emergence in 2013, so it's like last maybe I would say 5 to 8 years, containers are very popular, and now we can call both containerization and virtualization are equally successful, but they have their own differences and use cases for which we can use virtualization and containerization. So we'll discuss the differences and the other and yeah, definitely like software practices are evolving, and in parallel hardware technologies are getting a lot of enhancements and benefits as day progresses. So we'll talk about the development process, application architecture, application infrastructure a little later. But now we'll talk about more on the deployment and packaging aspect, where we'll compare virtualization with containerization. We'll try and put together like around 25 differences in this particular session, so that you get a fair better understanding on where exactly you can fit in virtualization and where we can consume the containerization advantages. Okay, let's start with some high level comparison. Okay, I'll try to draw a picture here. Maybe I'll try to use one of the slides here. So here, if you look at the differences, we have the infrastructure. When I say infrastructure, it is a combination of server hardware, operating, your memory, storage, processors, and so on. Similarly, like here, the infrastructure conveys the same. So hypervisor is a purpose-built operating system for running multiple virtual machines in parallel. Examples of hypervisor may be like VMware ESX, ESXi, Microsoft Hyper-V, Zen. These are all examples of hypervisor. So hypervisor is a purpose-built virtualization operating system that enables you to run multiple operating systems in parallel on the same hardware. So the operating system can be Linux, Ubuntu, or Red Hat, or Microsoft, or Mac OS. So any different operating systems can run in parallel. See, virtualization to start with, it is a hardware abstraction concept. When I say hardware level abstraction or hardware virtualization concept, see, when you want to run a virtual machine, it needs its own specifications of hardware. Meaning, see, for example, if you want to buy a laptop or a desktop, what you will think in mind? So you will discuss about how much capacity in terms of CPU you need, memory you need, storage you need, and you will choose an operating system to run on that particular device, right? Similarly here, each virtual machine has its own independent operating system, which means this guest OS will need its own share of memory, CPU, storage, and network, right? So here, the hypervisor takes care of sharing the hardware level resources to each of this virtual machine, right? So when you talk about virtual machine has got its own independent OS. On top of that, we will go and load the dependencies like binary files, libraries, and we'll install all the prerequisite, and we'll run the application, right? The very first difference is that, let me open up an Excel sheet here. Let's put together virtualization and containerization. So here, as I told you, virtualization is a hardware level abstraction concept. Okay, and containerization is a OS level abstraction concept. So if you look at the right side diagram here, you don't have multiple operating systems unlike your virtualization concept. In virtualization, what we have done is we have reduced the number of server hardware footprint in the data center. See, virtualization has reduced the number of server hardware because we don't need as many number of hardware in the past. For example, 25 years back, one particular server hardware will run only one operating system and one particular application. So that was the scenario maybe 25 years back. So let's put together some content here. So one hardware used to run one operating system, and on top of that, we used to have only one application on that, right? So let me type out here. So infrastructure, which means server hardware, and we have operating system, only one operating system. I mean, you cannot have two operating systems running in parallel. You can have only one operating system running in parallel. You can have dual boot and all those concepts earlier, but now you have a lot of different stuffs all together. Okay, let me uh, move it here, infrastructure, and we used to have only one hardware on one operating system and one application. Okay, so here it was very suitable at that time because the infrastructure used to have very limited amount of CPU, RAM, and capacity. So if you compare exactly the memory alone, it used to be only 4 GB capacity or 8 GB capacity 20 years back or 25 years back. But now the server hardware comes with 6 terabytes or 12 terabytes of memory, which is like 100 times from where we were in 20 years back, right? So you cannot run one operating system on such hardware and end up with a lot of resource wastages. So virtualization has helped with reducing the number of server hardware. Now you can run at least like 20 or 30 different virtual machines with 30 different operating systems on the same hardware, which means you have drastically reduced the number of server hardware running in the data center. So you can say like instead of 100 server hardware, we are just having only 10 server hardware, which automatically conveys the message that for having 10 server hardware, you just need to have only 2 racks, unlike 10 to 15 racks in the past. And similarly, you can reduce the number of top of the rack switches, the cabling connections. The data center size has drastically reduced. So with hardware abstraction, the size of the data center has come down, and you also have the benefit of having a device emulation, and you get all the hardware independent CPU, memory, and the network storage requirements for each of your operating system. So here we call it as virtual machine. Here in containerization concept, we call it as containers. See, containers virtual machine, let's do one thing. So container will have its own guest OS. It will have the libraries, it will have the prerequisite, it will have all the contents that that it needs, like any kind of scripts or anything to run your application code. Similarly here, containers does not have its own independent operating system. Instead, it shares the base OS, it shares the base kernel. Okay, so containers will have only the library files, the scripts, the code, the binaries, and then the dependencies for the application code. For the application code to run, you need specific libraries, dependencies, and scripts and binaries. So only that will be part of your container. So if you look at this diagram here, so you have the same host operating system. You will add the container engine or the container runtime. So the container engine or the container runtime, there are many in the current market. Maybe I'll list down a couple of examples here. Maybe the container runtime or container engine. Examples are Docker is the most popular. We have LXC, we have LXD, we have Rocket, we have many. Okay, so we have container daemon, container D. They go by small d. Even Windows has got its own container technology, both on Hyper-V platform and in a regular Windows Server OS. So they call it as Windows Server containers and Hyper-V containers. So there are many technologies or many different flavors of product that are available now. And on the virtualization side, we have the hypervisor that are there. The most famous one is the VMware ESXi, and you got your Hyper-V, you got Zen, you got the Promox. There are a lot of stuffs, KVM, and so on. Okay, the top 5 I've listed there. So here, the virtual machine is the product that gets created on virtualization layer, and the abstraction happens at the hardware level here. Each virtual machine needs its own independent CPU, memory, and so on. So that's why here we call it as hardware abstraction or device emulation. Okay, some people call it as device emulation. That is also fine. Okay, here on the containerization side, we have the OS level abstraction. It shares the same kernel or same OS. So there are some advantages and disadvantages in both the technologies. Okay, so you should not compare apple for oranges, or like it's not apple for apple. So they both have its own advantages, and they are used for different use cases also. So if you talk about virtual machine, if you talk about the segregation here, you get complete isolation or complete segregation at the OS level. Okay, because it has got its own independent OS and so on. So you get OS level segregation. But here it is at the application level, or it is at the process level. So they have separation only at the application level because it shares the same OS, same kernel, and so on. And here with hardware abstraction concept, we have reduced the number of server hardware, but you have not reduced the number of guest OS that needs to run your application, which means if you had 100 operating systems running in the past, even after virtualization, you still have 100 operating systems running currently. So you have to get 100 OS licenses or subscriptions in order for your OS to be actively used. Okay, so in terms of licensing, it has not reduced the number of OS license. Number of OS license or subscriptions still remains the same as traditional physical concept. Okay, so here containerization, it needs only one OS for each hardware, which means you have reduced 1/10 or you have drastically come down by 1/20th or 1/25th of the size, because containers can run in more density. You can run 30 containers on one single hardware or 60 containers in one single hardware. So number of licenses, you need only one OS license or subscription for each hardware. So that way you save a lot of OS license cost also. Okay, so this is the biggest cost benefit when it comes to containerization. Okay, and when it comes to OS level support, see, you can run multiple OS in parallel. So when I say multiple OS in parallel, you can have Linux, you can have Mac OS, you can have Windows, everything running in parallel on the same hardware. It can be different flavors of Linux also, but then here it shares the same single OS or the kernel, which means the application should have to run on the same base OS or the kernel. If it demands different OS platform, you need to have different hardware to make it compatible there. So here the compatibility aspect, you can run multiple OS on the same physical hardware, which is the biggest advantage when it comes to virtualization. And when you talk about the isolation or when you get this, I already talked about the segregation or the isolation here, right? And when it comes to portability, okay, both of them are portable, but to some extent. For example, when you talk about virtualization portability, you can migrate virtual machine between your VMware environment from VMware ESXi version 5 to 6 or maybe 6 to 6 different hardware. So portability is it is portable, but limited to the same platform or the flavor of product, like the VMware or Hyper-V or whatever. See, when it comes to containerization, they call it as package once and deploy anywhere. Meaning, you can create a container and you can run it on your physical server. You can run it on a cloud hosted environment. You can run it on a virtualized platform. So you can run it on anywhere. So you package it once, you run it anywhere. It's highly portable. Even the virtual machines are portable, but within it has to have some kind of compatibility checks and so on. But then here the containers can run anywhere. It's more portable and so on. And when it comes to flexibility, see, you can move it very quickly, and then you can size it, or you can change the configuration or the sizing very quickly. But sometimes in virtualization platform, most of them are hot plug and hot add, or those are all supported, but still it takes some time. See, for example, when you want to have auto scaling, or if you want to have more virtual machines created, it takes some time to create more virtual machines and spin up here. But then when you talk about containerization, with the image, it goes and creates multiple containers within seconds. So deployment, if you talk about virtualization, VM takes at least 15 to 30 minutes time to get created, whereas the containers can spin up in milliseconds. Okay, so that's the beauty. You can just say seconds. Millisecond, it is too aggressive. But then, yeah, so there is, when it comes to booting, okay, VM takes at least minutes to boot, whereas containers can boot in milliseconds. So that's the beauty here. So very powerful, very quick, and when it comes to performance, you get complete performance from the hardware level. See, if you look at the diagram, the containers get access to the infrastructure directly through the base OS here. When it comes to virtual machine, the virtual machine application has to go through the guest OS and then the hypervisor OS, which is the virtualization operating system, and then the infrastructure, which means it doesn't have, the application doesn't have direct access to the hardware, or direct access to the infrastructure is not possible for the virtual machine. So no direct access to the base hardware or the base physical hardware. Here, direct access to hardware is feasible through the base OS. So which means you get better performance here, but you get native performance, which means very aggressive, very powerful performance when it comes to containerization. The performance is very good. See, when you talk about memory requirement, or disk requirement, or the content size and so on, definitely virtualization needs more memory. The reason I say that, see, for your application, let's say like you need 2 GB. For an operating system also, you need at least 2 GB of capacity. And similarly, if you multiply by 10 or 20 guest OS, the guest OS alone needs 40 to 60 GB of memory and other hardware resources, plus the application. So definitely the memory consumption or the memory footprint is moderate or medium, because I'm comparing it with the physical traditional era. So you get kind of medium, whereas here you get very less memory footprint, or very small memory footprint is needed. It doesn't consume a lot of memory. Similarly, disk size definitely we need large. The reason I say that, your operating systems like Windows and all, it needs 100 GB capacity or 120 GB capacity these days. It can run with 30-40 GB, but still, like what I'm saying is, like a lot of organizations have a standard of running 100 providing 100 GB for your guest OS, which means it consumes a lot of unnecessary capacity when it comes to virtualization or VM, virtual machine. Here, it's very small or very tiny, because the containers are just having only the library scripts and the content, so it doesn't need a lot of capacity. So sizing, it is large sizing requirement. Here it is very tiny or very small sizing requirement. And since we have a lot of free capacity, so it doesn't consume a lot of storage or memory and so on, so the density of running virtual machines against containers are very, very less. So on the same hardware with the same sizing of memory and storage and so on, you can run maybe 30 virtual machine maximum. Similarly, here you can run up to 60 containers. The reason is it doesn't have its own OS, or it doesn't consume a lot of memory and storage. So you get a lot of space of storage as well as the memory. So you can run 2 to 3 times the same. Um, so the density is very high. You can run 2 to 3 times the number of applications. At the end, we are running applications on the VMs and the containers, right? Compared to the VM, right? So the density is very less, low density. Density means number of VMs running on the same hardware against the number of containers running on the same hardware. Okay, so here, this is the resource access, right? See, one more thing I want to add here. When I say access to the hardware or access to the base infrastructure, so here, whenever you want to access any features or any particular resources, the access for one virtual machine to another virtual machine or whatever, it happens through your hypervisor. So hypervisor provides access to resources and sharing and all kind of resource requirement. Okay, so there's and so on. But here, I think it's a little different here. So it uses the kernel level features, the Linux kernel level features. For example, maybe I'm not sure how many of you have heard about namespaces and C groups and so on. I'll talk about these different terminologies and concepts a little later. But when you want to access the resources and if you want to have some kind of isolation and some kind of segregation, it uses the concepts called namespaces, C groups, and so on. Okay, and okay, I'm talking a lot of good things about containerization. See, I'll come to the most important part now. So when it comes to the maturity in terms of technology or security and so on, okay, so containerization is very recent technology, right? Even though it is existing for last 15 to 20 years, the Docker became very popular after 2015 or only last 4 5 years. The technology is very popular. So it is emerging technology, but here when it comes to virtualization, it is a very mature technology because it is there in the industry for last 20 years and many organization has been using it and practicing it very heavily. Security, definitely virtual machine gives you complete isolation at the OS level. And for example, if there is a vulnerability in the kernel, let's take containerization as an example, it will impact all the applications running on it, or multiple applications will get impacted because every application share the same OS, same kernel, and so on. So definitely it is complex here when it comes to security mitigation and so on. But then here it is very mature and very robust when it comes to security practices in virtualization. So it's very mature and definitely containerization will evolve and it will have very good features in terms of security, but now there are some challenges, right? So next thing is the version control. When I talk about version control, see, when you want to have different versions of the same virtual machine and so on, what do you generally do? You go and take snapshots and you go and take backups and so on, right? But then in containerization, it is, they call it as immutable image, or they call it as the reason they call it as immutable. See, when you want to deploy any changes or when you want to add any features to your running container, you don't go and modify the running container. Instead, you go and create the changes in the image and then you deploy the image and um, get the changes incorporated. Okay, so it is a immutable image, so the containers has to go and get spinned up with the new features. It takes milliseconds to deploy the new image as a container, right? So it's very the changes deployed or incorporated or changed. Okay, so generally the images are stored in something called Docker Hub or any kind of image repository. But similarly, you have templates and so on in virtualization. So those will get stored in your content library or shared libraries in your VMware concept and other technologies. So you do have the centralized repo or the storage options. But here, the virtual machine templates, you can go and change the running operating system contents and we can change the configuration and the OS changes. Even the app changes can be done on the running VM. That is a very big risk actually. See here in containerization, they have a concept called version control. or they have a concept called everything will be getting deployed as infrastructure as a code, meaning you have a version control mechanism. Any changes that you make, it gets version control, and if you want to roll back, it is very easily you can quickly roll back whatever changes you have made in the containerization. Rollback is very easy, and then you have a very powerful version control system that is there. Okay, so I think we are very close to the number of comparisons here, but still I would like to have some similarities here. For example, when you talk about file system or networking or other concept, almost the conceptually they have very similarity. See, each VM has its own file system. Even in container, you can have each container can have its own file system, but not the kernel. Okay, but not the kernel. The kernel has to be a shared one. Similarly, you can have separate network adapters for your VM, separate network adapter, and then IP address, port configuration, and so on. Similarly, you can have each container can have its own adapter, IP, port, etc. Okay, so there are some similarities. There are a lot of similarities there, but here I just want to convey the uh, differences between the containerization and virtualization. In fact, even though we talked about the differences, see, there are different use cases for each of them. So we'll discuss what are the different use cases for containerization and virtualization in the upcoming videos. But now you should not compare apple with oranges. That's my final point here. So virtualization has its own advantages and use cases. Containerization has got its own advantages and use cases. Not all applications can run on containers. For example, there are some Oracle databases or heavy sized applications which still need its own um, capacity or chunk of memory, OS, and so on. And definitely virtualization is still needed for a lot of applications and a lot of security reasons and so on, because you cannot have one OS kernel sharing multiple applications on the same hardware. Okay, so this is what I thought of covering, 25 differences between virtualization and containerization. Thank you for listening.